This video is Mobile HF Wiring Part 2. Warning, we're talking about electricity. Use proper precaution. Let's discuss what size wire to use. Most modern amateur radio transceivers universally operate on normal 13.8 DC. On a mobile scenario, that normal voltage actually varies from below battery resting voltage, 12.2, to as high as 14.4 when the alternator is charging the battery. If we allow the voltage to drop much lower than 11.6 volts, most transceivers will simply shut off. Also, at a low voltage, the power output drops. Thus, it behooves us to minimize the voltage drop of our wire. The rule of thumb is not more than 0.5 volts. With that in mind, we need to know peak current draw. In both cases, the manufacturer's published figures are close enough. For the average 100-watt transceiver, the peak current is approximately 22 amps, which includes some parasitic draw like the cooling fan. A 50-watt FM transmitter is about half that, or 11 amps. Here is the formula for calculating the voltage drop for any given size and length of wire, including the slight drop due to the fuse and their holder. For the record, voltage drop is frequently referred to in amateur literature as I2R losses, but I2R actually refers to power loss. So here's the formula. If you don't want to do all the math, there's a very nice website to calculate it out for you. It's www.calculator.net/voltage/drop/calculator.html. Or another way to get you in the ballpark is this chart, which gives you a reference wire for a particular amperage and length. For example, an HF transceiver running 25 amps going 10 feet would need a 10 gauge wire, and a VHF radio running typically 15 amps peak would only need a 14 gauge wire for the same 10-foot run. Another reason to shoot for less voltage drop is temperature rise, since an automotive environment is hotter than a base one. Oversized wire, less resistance, will keep temperature rise to a minimum. Too hot of a temperature rise, and the insulation could melt. Minimal voltage drop is even more important if you're using an amplifier. For example, an HF 500-watt mobile amplifier draws between 25 and 40 amps average, with peaks above 100 amps, including the driving transceiver. Again, the wire selection should be based on peak power draw, not the average. This is why a trunk-mounted battery is a mainstay for high-power installations. Even then, the main feed from the front battery should be at least number 6 wire, and preferably number 4. Without a second battery, 2-aught wire is needed to achieve the same minimum voltage drop. And if all else fails, talk to a mobile electronics certified professional or an ASE certified mechanic about your ham radio installation.